Hey, we have here another integral on the board. We have here the integral of 1 over x cubed plus 6x squared dx. Okay, so I think we have kind of an obvious first step here is let's just factor the denominator because we have an x squared in common there. So what I'm going to do is let's actually rewrite this. I'm going to bring out my x squared, and then we're going to be left with inside the parentheses just x plus 6, and we'll still have our 1 dx in the numerator. But now this looks like a pretty good case for us to use partial fractions. So let's just look at this fraction separately from the integral for the moment. So we'll have our x squared and x plus 6. And the way we're going to want to do this, because this is just one term, we can use the repeat case. So how we'll do this is like I'll have an a over x, even though we don't have an x, but then we'll have another term, which is going to be b over x squared. And then for the x plus 6, we'll just write this as c over x plus 6, where we're going to want to find these a, b, and c values. See, if instead of an x squared here, if we had something, let's just say we had x squared plus 3x minus 5, then what we'd want, instead of doing this repeat factor case, what we would do is we would do something like just ax plus b. But because we just have this single x squared term, we can do this repeat factor case. And then from here, I can use the cover-up method to get some of my terms. Plug a 0 into the x squared term. We can just plug it in here. Cover up the x squared. When we plug this in, we're going to have 0 plus 6 is going to be 6. 1 over 6 is going to give me, for my b term, 1 over 6. And then next for the c term, we can plug in here a minus 6, cover this up, and plug the minus 6 in here. And if we do that, we're going to have 1 over minus 6 squared. This is going to give me 1 over 36 here. Now for this a value here, we can't use 0 because we already used it to get this term. So we need to use another value. Now at this point, we could get like a common denominator and work it all out, but I think it's going to be quicker if we just choose a value, some value other than 0 and other than minus 6. We have anything to choose from. So let's choose 1 because that's going to be easy to work with. So if we plug 1 in on the left side, we're going to have 1 over x squared, or 1 squared is going to be 1. 1 plus 6 is going to give me a 7 here, so we're going to have 1/7 on the left. Then we're going to have a over 1, so we'll just have an a. Then here I'm going to have 1/6 over 1 squared, that's just going to be 1, so we're just going to have a 1/6 here. And then we're going to have 1 over 36, and then this is going to be 1 plus 6, or 1 over 7. And then let me just isolate my a value, so we'll have 1/7 minus 1/6 minus 1 over 7 times 36. Let's get a common denominator for all this. So I'll multiply here by 36, and I'll multiply here by, I think 42 is what we need. And so when I combine all this, I'm going to have minus 7 over 7 times 36, but the 7 is going to cancel, and this is just going to be minus 1 over 36, and that's going to be our a value. Okay, now from here, all I need to do is take all this stuff here on the right side that we've transformed this fraction. We'll put it back into our integral, and we can finish it off. Okay, now we're ready to integrate, and just to make it clear, we have our a value here. This was our b value that we found, and this is our c value. So starting with this first one, if I integrate this, I'm going to have minus 1 over 36 natural log absolute value x. Then here, the funny thing is when I did this on paper and I integrated this, I got natural log of x squared. Clearly that's wrong, but let's just do this. So when I integrate 1/6 over x squared, I'm going to have minus 1 over 6x. And then here for this last term, we're going to have 1 over 36 natural log absolute value x plus 6. And I'll just add a plus c on the end, and that's it. Okay, good problem. Thanks everyone for watching. Have a great day.